composite function, we mean by mixing two functions, putting f in the inside g, or putting g of x inside f of x. How can we put these? Or maybe we have more than two functions. We can put f in g and g in h. Now let's talk about the types that we need to use in a composite function. If we have two functions, one of them x squared minus 1 and the other one is square root of x plus 1, how can we add those two functions? That's easy, guys. Look, if we have x, f plus g, and then in a bracket, parenthesis, let's say, of x. So we will give this x to both. So it becomes f of x plus g of x. Okay? And then f of x is, what's f of x is x squared minus 1. G of x is square root of plus square root of x squared plus 1. Can we remove anything? Can we simplify anything? Nothing. So leave it. If we can, yes, we can do it here. Okay? F of, let's say this one is g of x minus f of x. Let's say g minus f. Okay? Give x to both. So g of x minus f of x. What's g of x? G of x is there, square root of x minus 1. Okay, be careful. Minus f of x is x squared minus 1. But here you have to pay attention. This minus is for the whole f. It means this minus for all of them. So put this in a parenthesis and then minus go to inside. This becomes plus and this becomes minus. And you can't simplify anything here. Guys, think f and g. If we have f plus g of x or g plus f of x, those two will be same, guys, will be same answer. But for this one you can't replace them. If you change the place of g and f, it will be another example. Okay, f multiply g or g multiply f, that will be same. Okay, because here if we multiply 2 by 3 or 3 by 2, it will be same. So in multiplication we can change the places of the function, and in addition to, but in subtraction, be careful, we can't. Give this x to both, f of x multiply g of x, and then instead of this f of x, write the equation x squared minus 1. Instead of this g of x, write the equation x minus plus 1. Okay, and here what should we do? We have to multiply this to inside, and you know these steps. How about this function f over gx? So give this x to both, f of x over g of x, and then instead of f of x, write x squared minus 1. Instead of g of x, write square root of x plus 1. Okay, so here, guys, we have to say the g can never be 0. Okay, g of x, where g of x can never be 0, because in any fraction in math we have to talk about the denominator can never be 0, because it will be not real number. This is all types of subtracting, addition, multiplication and division between two functions. But we have another one, f of g of x and g of f of x. This one's different. This one putting g inside f or putting f inside g. And there's another thing that's different from these. We are going to give this x to the nearest letter, but here we gave to both. Here we are going to give this x to only the nearest one is g. So we are going to write f, and we will open a bracket and give x to g. It will be g of x. Now, instead of this g of x, we have a function. Can I write this instead of g of x? Yes, we can write square root of x plus 1 and in a bracket and this if. Guys, look, just I wrote instead of g of x, let's say this is equal to square root of x plus 1. Now, we have f of x is equal to x squared minus 1. Okay, this is f of x. Let's say it's equal to x squared minus 1. But this is not f of x, this is f of a bracket. So can I cancel this x and write the bracket instead of this x? Yes, x plus 1. Now we can cancel 2 with square root of x. So the answer is x plus 1 minus 1, which is equal to x. But guys, be careful. The domain of this composite function will be different and it will be a little bit difficult for you. If you want to learn the domain and range of a composite function like this, you can click on the description below. It talks about the domain and range of a composite function. G of f of x. How can we find this, guys? We will give this x to the nearest one. Okay. G of f of x. Now, what's f of x? We can say instead of f of x equal to x squared minus 1, write x squared minus 1. Okay, and write this g again. Okay, this is g of this bracket. And think about g of x is equal to this, guys. G of x is equal to what? Square root of x plus 1. And then, instead of this x, we have to clear the x and write this bracket, x squared minus 1. Okay, instead of that, let me write in another color, sorry. X squared minus 1. Okay, I wrote the bracket. Then minus 1 plus 1 cancel and it becomes what? X squared. Then cancel those two, the answer it becomes x. Okay, cancel those two, it becomes x. So now, guys, if we have x or an absolute value of x, what is the domain of this function? Maybe you will say all real numbers, but don't decide like this. Please, for domain and range, it will be hard for you guys. Click the description below. This is all about the composite function. But guys, f of x not equal to g of x always. Okay, f of x not equal to g of x always. For example, here we have square root of x. Those two cancel, it will becomes x. Okay, but here we have square root with x squared. It becomes, we can say, an absolute value. It becomes positive and negatives. Okay. Hope you understand this, guys. Please make sure. How can we find this graphically? How can we find this graphically? Now I'm going to show you how to do it graphically. For example, now, guys, how can I find g of f of g of 3, let's say? Guys, let's say this is an example, okay? This red one is g, and the blue one is, look, I name it f. How can I find f of g of 3? You have to know how to find graphically also. Give this 3 to g, okay? So it becomes f of g of 3, okay? G of 3. When we say g of 3, sorry, it means g of x. So find 3 in x. Where's 3? 1, 2, 3. Don't say this is also 3 because we have g of x. So find in x 1, 2, 3. And then what is the answer in the g? G we mean by the red one. The red one is, look, the red graph is opposite of 3. We have a graph here, let's say. It is about minus 1, 2, 3, 4. It's about minus 4. So the answer of 3 is minus 4. This is equal to minus 4. Now, f of minus 4 is equal to what? That's it. G is finished. Find minus 4 in x. We have f of x. So x, it becomes minus 4 for the next function. Find minus 4. 1, 2, 3, 4. Don't say this is minus 4. This is the answer for this red graph. But now the answer, it becomes the x for f. 1, 2, 3, 4. This is minus 4. And find the graph in minus 4 for f, for the blue one. So the graph is here. So the answer is 4. So f of minus 4, the answer of f of minus 4 is 4 on y-axis, okay? So the answer for f of g of 3 is 4. Now let's check. G of f of 3 is equal to what? Give this 3 to f, g of, f of 3. Okay, f of 3 is equal to what? 1, 2, 3. Okay, and then let's say this is let's say 3, but this goes to up too much. Let's say like this. 1, 2, 3. So the answer for 3 is, let's say, minus 3. So plus 3. Okay, plus 3. So then g of 3. Again, g of 3. The answer of f of 3 we said is 3. Now g of 3, find 3 in the x-axis, 1, 2, 3, and go to the g. G is the red graph, is minus 4. So the answer is minus 4. So now we proved that f of g not equal to g of f. Always, okay? In this function it is, they are kind of equal, but here they are not equal. So be careful, f of g and g of f, they may not equal, okay? And the most of them is not equal. Please study hard on those two if we find the equation of the composite function, and how can we find it graphically. Thanks for watching the video. Don't forget to study on the domain and range of the composite function. You can click on the description below.